Hi, in this video we're looking at the differential of the logarithmic function. As I did with the previous situation with the e-graphs, e-functions, the exponential functions, we're going to start off by looking at the graph of ln x and its gradient function that goes with it. So if I go across to GeoGebra, I have already drawn the graph of y is equal to ln x. It's the red graph that runs over here. And here we've got our tangent to the graph, we've got the point A, and here we've got the derivative point plotted over here. It's got the same x value as the point A, and the slope of the graph at point A is this value down over here. We can see it over here. We've got the slope is at 0.15, so the value of that point is 0.15. A is the point 6.559 and 1.89. As before, I'm going to draw my point A along the curve. So I pull it along the curve, and we see that we get our gradient function being plotted underneath. Is it a straight line? No, it certainly looks like a curve of some sort. And keep on pulling that round. And we seem to be getting a curve that looks quite nice. So I'll just run that around so we get all the points that go in between them. A little bit harder when we get higher up because the points are much further apart. And we've got a curve now. And we need to try and figure out what that curve looks like. Well, you hopefully will recognize this curve as something you did back in fifth form, and that's a hyperbola. So in other words, y is equal to, let's just start off with 1 over x. No, that's 1x. 1 over x. And although we don't get the bottom part of the hyperbola over here, we certainly have picked up the hyperbola in the first quadrant. And so we seem to now, or we have now got the gradient function for the logarithmic graph. So in other words, when I take the derivative of a logarithmic graph, I'm going to come up with the hyperbola 1 over x. Now, we can see that graphically, but we can also see this algebraically. So how does this work algebraically? Let's get some lines in there. Well, I've got my function y is equal to the ln of x. That's clearly in log form, so I'm going to take that back to exponent form, and the base I'm working with when I'm dealing with natural logs is the base e. So in other words, I know that this thing can be rewritten as e to the power y is equal to x. So now I have an equation in where I'm expressing x in terms of y. So I can derive that. I can say dx dy is going to be the derivative of e to the y, and we know that the derivative of e to the y is simply going to be e to the y. Now, I've just gone and said e to the y is the same as x, so in other words, this thing can, instead of writing e to the y, I can just call it x. So in other words, I've got that dx over dy is equal to x. Of course, if I go and rearrange that, flip this around, I can say dy dx, and that's going to equal 1 over x. And there is the hyperbola that we saw in the graph over there, the 1 over x part that we've got down the bottom here. So we have an algebraic explanation for this as well. So the derivative of the generalized expression y is equal to the ln of some function of x, well, we need to try and figure out what that looks like. So I'm going to deal with this in much the same way as I dealt with the previous one. I'm going to say let f of x equal u, And so my function now looks like this. It's y is equal to ln of u. In other words, I can say dy du, that's simply going to be 1 over u. And if I look at my previous part, if I want to find du dx, well, that's simply going to be the derivative of f of x. So now using my chain rule, I can say dy dx, that's simply going to be dy du multiplied by du dx. And if I put in what I've got there now, dy du is going to be 1 over u. Du dx is simply going to be f dash of x. And if I give myself a little bit more space here, because I'm going to need a little bit more space, I can say, right, well, this is 1 over u. U was simply f of x, and I'm multiplying that by f dash of x. And so the derivative of y, dy dx, is simply going to be f dash of x over f of x. And that's our generalized formula. The derivative of the ln of some function of x, let's get that x written correctly, some function of x dx, that is simply going to be the derivative of f of x divided by f of x. So, in general terms, that's what it looks like over there. It's a more formalistic term. So, if we just go through some examples of this, here is my function, this part that we're dealing with over there. So, if I want to find the derivative of this, dy dx, that's simply going to be the derivative of this part over here. So, in other words, it's going to be it's going to be 3 times 2x to the power 1 over 3x squared. In other words, 6x over 3x squared, which will simplify down to 2 over x. If I take a look at my next one, dy dx, I take the derivative of this part over here. So the derivative of 2x is simply going to be 2, and I'm going to divide it by the function itself there. That's going to be 2x plus 3. Here, I've got y is equal to, if I rearrange this, I've got y is equal to the natural log of 3 plus x to the power of a half. Now I've got a bit of a compound function happening here, so I need to possibly give myself a bit more space in order to tackle this one. So because it's a compound function that I've got happening there, I need to make a substitution. So I'm going to say let 3 plus x to the power of a half equal u. Then I know that du dx is going to be a half 3 plus x to the minus a half times by the derivative of the bracket, which is simply going to be 1. My function now looks like this. It's now y is equal to ln of u, and so therefore dy du is going to be simply 1 over u. And that allows me to say, right, dy dx is going to be 1 over u times a half 3 plus x to the minus a half. Now that's a little bit messy as it stands there, so we need to expand that out a bit more. This is going to be 1 over 3 plus x to the power of a half. That half, I can extend this line on. That half is going to be over there, 1 over 2. And this 3 plus x to the minus a half, that minus a half is simply going to pull this down to the bottom. We're going to have this x plus 3, no, 3 plus x rather, 3 plus x to the power of a half. And what does it leave me with? Well, on the top line it leaves me with 1. On the bottom line it leaves me with 2 times, now I've got this 3 plus x to the power of a half times 3 plus x to the power of a half, same base, so add the indices, and I'm going to be left with 3 plus x to the power 1. There's my derivative of that. The next example is a situation where we have a product. And that hopefully shouldn't be too much of an issue for you because we've dealt with products already. So as before, I'm going to split this up into 2 parts. There's my U, there's my V. I might want to at this stage, no, I'm not going to do that. So if I wanted to look at, wrong color. If I want to look at dy dx, I know it's going to be v, so in other words e to the 5x, multiplied by the derivative of this thing here, derivative of u. Derivative of u is going to be the derivative of that thing, of what's inside the bracket, and that's simply going to be 2e to the 2x over 1 plus e to the 2x. That's the derivative of a log. And then we need to add on the next part, which is going to be u. So it's ln of 1 plus e to the 2x multiplied by the derivative of v, and that's simply going to be 5e to the 5x. Now, if we tidy all of this up, whoa, it's a bit messy, isn't it? I can certainly take out e to the 5x. And what am I left with? I'm left with 2e to the 2x over 1 plus e to the 2x. And to that I'm going to add 5 ln 1 plus e to the 2x. And I think that's quite complicated enough, and I'll leave it at that stage. And finally, because we've dealt with them already, we're going to deal with the product. Here is u, there is v. So let's get, first of all, what is du dx? That's simply going to be 3e to the 3x. dv dx, that is going to be derivative of what's inside my bracket. It's going to be 3 over 3x minus 1. And now I can get on and tackle this part, dy dx. Remember, this was going to be v times du dx minus u times dv dx all over v squared. That's the formula that you have on your formula sheet. So I've got the ln of 3x minus 1 multiplied by du dx, which we've got over here, 3e to the 3x. From that I'm going to take away u. U was e 3x minus 1. Multiplied by the derivative of v, and that is going to be 3 over 3x minus 1. And all of that was going to be over, so I just need to put a bracket on that, all of that needs to be over the natural log of 3x minus 1. And all of that's going to be squared. And I'm just going to leave it like that. Right, go and do some practice now.